listening to B2B Tech Talk with Ingram Micro, the place to learn about new technology and technological advances before they become mainstream. This podcast is sponsored by Ingram Micro's Imagine Next. It's not about the destination. It's about going someplace you never thought possible. Go to imaginenext.ingrammicro.com to find out more. Let's get into it.
Welcome to B2B Tech Talk with Ingram Micro. I'm your host, Shelby Skrhak, and our guest today is Erik Salo, Vice President of Products and Markets. Erik, welcome.
Hi, Shelby. Thanks.
Well, today we are talking about self-healing block storage with Seagate and kind of the next generation of hard drives. But first, Erik, just tell us a little bit about yourself and how you made your way to Seagate.
Well, thanks. I started out, actually, my first job was in the tape industry quite accidentally. And, it's going to be 30 some years. And I remember I took this job in the tape industry and they said, hey, welcome to, I think it was Carlisle Memory Products. Mm-hmm. And we make quarter-inch cartridges for tape drives. And they said, welcome to Carlisle. This is really a great place to start your career. But, tape's only going to last a couple of more years, maybe 3 more years. So you're probably going to need to get another job after that. But, welcome here and, enjoy your time. And, that was 3 days ago. And it's amazing how much has changed and also how much is the same since that first job. I spent kind of half a decade in that market. Then I went to the chip industry, National Semiconductor, and the AMD. Love that ride, and then back to storage. And I've been now 10 years at Seagate, and that's been really exciting.
What an entrance to career that, well, it'll be good while it lasts, but, maybe get those help wanted ads, right?
Yeah, it's not going to last very long. Tape's on its way out the door. Storage is different now.
Yep. Well, so let's talk about then storage. I mean, we know that hard drives have been around for a while, but I think maybe there's an idea that they're not as advanced as far as technology as we would think. So I wonder if you can tell us a little bit about Seagate's hard drives today. I mean, I know I want to get to the kind of next generation of hard drives, but when you hear something like self-healing block storage, that's not something you would necessarily expect. So tell us about Seagate's range of hard drives.
Well, one of the neat things about working at a technology company like Seagate is you get to see, really what goes into making these devices. And I think a hard drive is probably one of the most high-tech devices created by humans right now. You think about the extreme flatness of the disks and the tiny size of the heads, and we're continuing to find ways to put more and more bytes reliably into that, kind of familiar 3.5-inch form factor that everybody knows about. And now we're actually in our next generation of drives, we're using lasers to heat something like a billionth of a square meter of the surface to 200 degrees C for a billionth of a second, so we can write the data in more and more granular bits. And it's just incredible, just all the technology that goes into it, and to see that we do this at scale and we make something number of hard drives a second, and they're reliable, and you can put a disk in your computer and you feel really safe about your data, right? It's just a real accomplishment of technology, and being able to see that up front is fun.
I wonder if you can take us a little bit of a kind of a crash course, because from that initial the original hard drive of hard drives with tapes and moving to what we are today, how have you seen it evolve over the years?
Well, it's a little bit. I mentioned I spent about half my career in the storage industry, and then about half my career in the silicon industry. And to use an analogy, the silicon keeps getting, the traces keep getting smaller. The process technology keeps going, and like at every step, I've just been astonished as an insider to do it. I remember I was thinking, this is just 20 years ago, I was thinking we'll never go sub-micron, right? We'll never get to below 100 nanometers. There's no way. And of course now we're at 5. And then I'm like, well, we'll never get below the wavelength of light. That's impossible, right? Nobody can make a conductor smaller than the wavelength of light. That's what you use. And now of course we're using extreme UV. The analogy really works for this hard drive technology, where just over and over again we think we've ended up at a physics breakpoint, and then the scientists cleverly figure out some way around it. And like I said, our next generation, we're actually heating up the media to make it more easy to record for just a tiny amount of time, a tiny amount of area for a tiny amount of time. And and then we can keep going. So, we're, the industry shipping in the low 20s now, 20 terabyte-ish drives. We see in our lab 30 terabyte drives, and we expect that this technology will get us to 50 terabyte or maybe even 100 terabytes in the future. So it just keeps going. And you think about how much data that is, right? It's just it's an incredible amount of storage.
Well, and that brings me to my next question is that, the need for all of this storage is obviously the just incomprehensible amount of data that we are creating out there. Can you tell us a little bit about, in retrospective, how this has changed? How much data is being produced? I mean, I know we've heard the statistic about, that the amount of data that we've produced in the last year is probably equivalent to, all time combined. What's the updated version of that stat, and what is all this data?
That's the real story, right? It's I love to kind of geek out on the technology, and it really is pretty neat. But, the real interesting thing that's going on is that, humanity's data is doubling every 3 years. And it just gets from unimaginable amount of data to more unimaginable amount. And the real change that I see, I think this is kind of an exciting thing, and we're really just in the infancy of it, is why are we making all this data, and why do people think they want to keep it? Mm-hmm. Because they don't just keep it locked in. They're actually learning about ways to get value from the data. And that's the real story. Today, computers can look at data and learn things that are useful to us. And that is a real revolution. You think about, essentially really fast characterization technologies like fast Fourier transforms, they can characterize just huge amounts of data. And then these clever AI algorithms, random forest and things like that can actually take these huge data sets and go through them and come up with some kind of insight that we find interesting and valuable. And that's the real story. And I think, if you think about that as a book, the story of how we're thinking about machine learning and these big data sets, if you think about it, the story of that as a book, I think we're kind of early in the first chapter. And so, most of the exciting stuff is before us. And I just see no end to the amount of cool things you can do when you're able to, one is, store this huge amounts of data. And that's what we think about a lot at Seagate. But also, once you have it, what do you do with it? And these clever computer programs that are thinking about it and saying this is a valuable insight. That's the really interesting change that's caused all this creation.
Well, I'd love to drill down more into, again, why is the amount of data that we're producing tripling every 1 year or every 3 years?
It's doubling every 3 years, from a lot to a lot.
Yeah. So you alluded to this, that this idea that maybe we feel like we need to keep all of this data, but again, where is the data coming from?
Well, it's let me use an analogy. So we've been doing video recording for forever, 50 years, some long time, decades and decades. But for the longest time, up until just recently, the only way to really get value out of that recording that you have was for a person to look at it.
Yeah.
Right. So somebody actually had to watch it. You watch the CSI, and they're find the cameras, and there's some person looking at it. Well, guess what? The computers can look at the video now and learn things, and they're getting really clever. So that is the big change, I think, that is just making a complete difference, is that now the computers can look at data, then all of a sudden you can go through, not just twice as much data. You can go through 1 million times more data, many orders of magnitude more. And then we do these really clever things like kind of meta-analysis, like analysis on top of analysis. And that's what's really driving all this increase.
So, of course, AI and the amount of data that's out there, that's what's making this possible. And it's certainly more advanced than any human could even imagine. So when we shift to looking at the technology itself, you started to talk about this, how these next gen hard drives are being created. Can you tell us a little bit more about that process? Because you're saying that, we got to a point where, okay, surely there's not another, iteration after this. It's we can't go any smaller, but yet we find another way.
Right, every time, right? It gets more. Well, one of the things we think about a lot. Let me just give you a quick example. So when I started at Seagate, I remember we were looking at object store systems. Objects are a way to store data, like a file, but it's kind of amenable to these really big data sets. I think big data wants to be object in a lot of ways. And when I first was looking at the architectures, it was something like one server for every 12 hard drives, like you put them in like a 2U12 container, and then you'd have a server to do it. And the hard drives were probably, 1 terabyte back then. So you'd have one server for every 12 terabytes. Well, now the drives are north of 20 terabytes, and we have more than 100 of them in a shelf, right? We have these 4U boxes that are 106 drives in our case. So you have a couple of petabytes per computing element, right? So it's gone from 10 or 12 terabytes per server to 2,000 or 2,100 terabytes, and it's just keeping going. And so, from an architectural point of view, the question comes up right away. It's like, well, what do you need to do differently to efficiently manage all that storage? And that's something that we spend a lot of energy on, because our customers, they don't want to solve this problem at the bit level. They just want to buy something that works and keeps their data safe and is cost effective. And so, Seagate spent a lot of energy thinking about products like our self-healing block storage, where we have a product called Core Vault, where literally we do data protection inside the box. We actually take the data and spread it out across the hard drives inside that box. And then we have clever things like, if one surface of a drive fails, instead of taking the whole drive away, which then, if it's 20 terabyte drive, you have to move 20 terabytes through your network. We say, you know what, let's just take that one surface away and put the drive back in service at 95% of its previous capacity, and that way you didn't disrupt and didn't have to move 20 terabytes. You only had to move half a terabyte, something like that, or 1 terabyte. So we're doing things like that to make these big systems easier to manage at a solution level, so that companies can really spend their time doing all the cool stuff we were talking about earlier, which is figuring out how to get cool and more valuable insights from these neat data sets.
You mentioned the self-healing block storage. A little bit about that process. Where, I guess, in terms of perspective for where Seagate has been a leader in that space, how did we come to this point where we're able to not just identify a problem, but it's self-healing? I guess if you can tell us a little bit about that process at Seagate and why that's so unique or obviously important.
Sure. So let's think about the problem that we're trying to solve. So for the longest time, especially object stores, were basically built with something called JBODs, right? And JBOD just stands for just a box of disks, or just a bunch of disks. And what you do is you'd have some software that runs on a server somewhere that says, okay, I've got a bunch of boxes of disks, I've got 1,000 disks, and I want to manage them. Now I'm going to do all the work, right? I'm going to decide which block of data goes on which drive. And if a drive fails, I'm going to handle rebuilding the data that wasn't there, or that we lost, and putting it on other drives. And then we're going to put a new one in, and we're going to rebalance it. So, forever these object stores, and before them the RAID boxes, if you've heard of RAID or SAN boxes, SAN, essentially the software would have to do that. And that actually, in the beginning, that was a tremendous savings over kind of the IT 2.0 systems that were being created, or many dollars per terabyte. When you did this in the software level, it was a good deal. That was 10 years ago or 15 years ago. Now, fast forward to today, a lot of people are building hundreds of petabytes worth of storage, right? Thousands of disks worth of storage. And the overhead, both in compute power and software complexity, to manage all those devices and do all that stuff that I just talked about to those devices, all of a sudden that's a bad deal, right? All of a sudden that's expensive. And so what Seagate's done is we've actually created, the way I look at it, like a Core Vault is not 100 individual disks. It's think of it as one big 2 petabyte disk, and all that complexity inside we've taken care of with our custom technology. We have an ASIC that does data protection and handles all these failures in these neat ways. And that way, the people who are creating the system don't have to worry about every individual drive. They only have to worry about every collection of 100 drives or something like that. And so we're trying to make the problem a couple of orders of magnitude easier to solve, because as these data sets get bigger and bigger, the complexity and the cost associated with managing every storage element gets more and more expensive.
How does that type of innovation and reliability make a difference for the bottom line for companies and for Ingram Micro partners that are listening to this and trying to design these technology stacks and trying to service their clients?
Well, the way I look at storage is it's really a combination of two things. people buy storage on cost and risk, right? And everybody has a certain amount of risk they're willing to take. So, if you just have a PC, maybe you're okay putting your pictures on one disk. But if you're building a big store, you want to have some kind of significantly more robust system with some number of nines of reliability. So you have a certain amount of risk you're willing to take. I want this much reliability. And then at that point, it's whatever the least costly solution is that gives me that reliability. Those are the two factors. And so what we're doing is we're creating more reliability for less cost, because again, the people that are using these big data sets, their core competency is not to go and design how to store a bit of data. Their core competency is to how to get value from that data. And we want to make the storing of it safely as easy and as low cost as possible. So ultimately what we're doing is we're reducing the cost of reliable storage.
So looking ahead at kind of when we say the next generation of hard drives, what does that mean?
Right now, like I said, we're looking at 30 terabyte hard drives, and we'll release them in the relatively near future with our HAMR technology. So the next generation of hard drives actually has this laser inside of every head, right? So there's 20 surfaces on a modern hard drive, 10 disks, and there's a tiny little laser with a tiny little lens embedded in each head that allows us to heat up the media before we write it, and that allows us to make the hard drives bigger and bigger. So that's the next generation of drives are just amazing in what they're able to do. And this is going to be kind of one of those big steps, right? I talked about in the chip industry, we went submicron, we went, from light to UV. Well, the HAMR technology, this heat assisted technology, is one of those big steps in hard drive technology that is going to allow us to just keep going as far as density.
What type of density are we talking about? Or I guess what's possible with this type of HAMR technology?
Well, like I said, we are quite confident that we'll be able to, in the future, achieve a 50 terabyte hard drive. And it's possible maybe even double that, so maybe even 100 terabyte hard drive with this technology. And then, by the way, beyond that, we have ideas as well, right? But it looks like this HAMR technology, can go as high as 50 or maybe even 100 terabytes in a standard drive.
And it's a little bit of a kind of layman's check when we say, 20, 50, 100 terabytes. If you were to give us an analogy of how much data that is, what would that be?
Oh my gosh! So I tell you, I can't even imagine it.
Right.
I know I'll get it wrong, but like from the beginning of time itself till like sometime in the mid 70s, somebody estimated that humanity, like every book ever written, every letter, every newspaper, everything was like 3 terabytes or 10 terabytes or something like that. So like when you've got 20 terabytes, 30 terabytes, 50 terabytes in one little 3.5-inch hard drive, it's just mind blowing, right? And like, it's like if you printed it out, it would go to the moon. There's all these different kind of interesting analogies. But also just as interesting as the growth is that the data is growing much more quickly than we're actually saving it. So if we look at the percentage of data that is stored as a percentage of the data created, it's actually getting lower and lower every year, mostly because we're just creating so much more than we're able to keep, right? So it's like, even though the numbers are going up like crazy of how much data we're storing, the data that humanity's making is going up even faster.
Yeah, we could probably use a few less of the... We don't need to save everything we're creating, right?
Well, yeah, it's not that we need to, it's what's valuable, right? It's really not a need, it's what's there. Like, for example, like when we were talking before the podcast, I was showing you one of the new image, AI image generators, DALL-E, and we typed in what was it, like tall grass in front of a house for sale or something like that.
Yep.
And then what showed up on the screen?
Yeah.
Right. Exactly that.
It's amazing.
Yeah. So how does it know? Right. That's the thing, is how does it know? Well, because computers aren't, at least in my opinion, they're not smart per se. They don't actually understand what tall grass is. But what they do is if you feed them enough information, and they'll make some kind of characterization of that in a mathematical form, like so usually with a Fourier transform. Then if you feed them, 1 billion images and say, well, this 10 million of these images, when the math looks like this, it equals tall grass. Well, then it just remembers that. It just says, oh, and so when somebody asks me for a picture with tall grass in it, I'll go and I'll find some pattern, mathematical pattern that matches that. and show it to you, right? And when you type it into your web browser, it looks like magic itself. But really, what's happening is that there's a lot of data behind it, and then there are these really interesting machine learning algorithms that have become, again, I think we're just in the very beginning, but they've become increasingly more clever at seeming smart, in that when you ask it to do something, it says, "Oh, I know what pattern of numbers represents that thing. Let me show that back to you." And that's what's happening. None of that happens unless you have a lot of data.
So there is a use for all of those. So all of our teenagers' TikTok videos and all of that data, right?
Well, maybe not the TikTok.
I know. All right. Well, as we do start to wrap up our episode, we always ask our guests the same final question, and that's, where do you see technology going in the next year? So, let's get our crystal ball out and our genie hat on, I guess, if that's a thing, and say, where are we going to be in 2023?
Well, this is such an exciting time, right? This is like a golden age in our industry right now, as far as the innovation that's happening. So, what I see is an increasing number of companies you wouldn't think of, right? Companies from almost every area of technology going and learning how to get value from these big data sets. Over and over again, every area of technology, from machine shops to genomics to surveillance, all these kind of applications are learning how to use this big data. And of course, our job at Seagate is to make it safe and easy to store your data in a cost-effective way. And so, we're thinking about how do you do that at ever increasing scale. But the thing that is exciting for me is that we just don't know what we don't know. And every couple of months, something new comes up. I'll give you an example. I was at the Supercompute last week, and we did this panel on artificial intelligence, and one of the panelists was a computer, right? And it was really good.
Really?
So yeah, the moderator went to what's called GPT-3, which is a kind of a natural language processing engine. By the way, GPT-4, I believe, is just about to come out. Very exciting for the nerds among us. But they asked us questions, and then they asked the computer questions, and oh my goodness! So I will say that the worst answer that the computer gave was probably worse than any of the people. But the best answer was better.
Yeah.
Yeah. We looked at the computer's answer, and I'm like, wow, that's way better than what all of us said. And
wow.
And so oh my gosh, even right now at the very beginning of this, we are getting to the point where it would be kind of hard to tell if it was a person or not. And so just think about, if we're at 0.01% of our capabilities, what's going to happen in the next year, in the next 5 years, in the next 10 years. That's exciting. And that's, I think, the really big story here is all this really interesting innovation that's happening.
Yeah. Well, for listeners who have any questions about anything that we talked about today or want to find out more, how can they reach out?
So reach out to Seagate. We've got a really, really robust field team to talk to. If you go to our website, you can talk to an expert. You just push the Talk to an Expert button, and you'll be glad to know it doesn't get to me. But we'll have a qualified person come and talk. And like I said, this is just exciting stuff, and we spend a lot of energy making it easy for our customers to build these big systems that store a lot of data.
Excellent. All right, Erik. Well, I appreciate the time and insight. Thank you so much for joining me.
Thank you very much. It was fun.
And thank you, listeners, for tuning in and subscribing to B2B Tech Talk with Ingram Micro. If you like this episode or have a question, please join the discussion on Twitter with the hashtag B2B Tech Talk. Until next time, I'm Shelby Skrhak.
You've been listening to B2B Tech Talk with Ingram Micro. This episode was sponsored by Ingram Micro's Imagine Next. B2B Tech Talk is a joint production with Sweetfish Media and Ingram Micro. Ingram Micro production handled by Laura Burton and Christine Fan. To not miss an episode, subscribe today on your favorite podcast platform.